is the cup anemometer that we'll be using for the experiment. The rotation is caused by the wind. Inside this is a switch that turns the signal on and off. So when we feed power into this, the speed of the wind that causes it to rotate, the switch inside turns power on and off, and from that we get a wave from which we can whose frequency we can read and use that to compute the speed of the wind. This here is a wind vane which we'll use to find the direction of the wind. As this travels through the wind, it points in the direction of the wind. Inside here is a potentiometer whose resistance varies depending on the direction of the wind vane. And using the resistance in this, we can compute the direction of the wind.
Plus like 28x.
Very good job.
This is our team's cup anemometer. When the wind blows, it spins and it gives us a square wave. By looking at the square wave with our Fez Cobra 2 board, we can measure when the pulses go high and when they go low to determine the frequency of the signal. Unfortunately, this can require pulling very quickly. To avoid having to pull at high frequencies, we're using a hardware counter. Now, we don't want to use a very wide bus between the counter and our device, so we tried to come up with a counting method that would be able to use a hardware counter, which still had maybe only a 4-bit bus or so. Now, suppose that these different columns represent the values within our counter at 3 different points in time. Now, you'll notice it keeps going up, so these could very well be sequential moments, but clearly we're not pulling very quickly. Let's suppose, though, that we're pulling fast enough that we're seeing every change in this 8-bit. Now, the way that our algorithm works is, every time we see a change in that bit, we assume that our cup has given us 8 pulses. So what we do is we say, okay, it's changed once here, so we add 8. It's changed once here, so we add 8. And then, at the end of our polling period, we take the lower bits at the beginning of our polling period and subtract, or the lower bits at the end of our polling period, and subtract the lower bits from the beginning of our polling period, and we say that we've seen 15 pulses. Now, let's consider how many pulses have actually happened. Over here, 16 plus 8 plus 1 is 25. 8 plus 2 is 10. So in the meantime, we have in fact had 15 pulses on our counter.
51, 50,
54,
49,
52,
47,
52,
46, 42.
45.
Oh, what?
Hold it tight though.
Nice.
Okay,
It's
nice.
going to give you a little bit of torque.
45,
45,
45,
42,
45,
41,
45, 44, 43,
45,
44,
45.
Cinema is really good now.
Yes,
That's pretty
not
awesome.
bad.
This is awesome.
39, 39. Look like we have some wind out there. 42.
Might depend on where I hold this thing.
37,
38.
39.
You know what? This video should better not go to the stable trail because like we go in 48 or 50 in the like 30 zone.
No,
it's
Oh no, 3 kilometers. Oh, that's right. Yeah.
Although, it's funny, it almost sounds like this thing is giving us faster updates on our speed than the GPS is.
Oh yeah.
That's pretty awesome.
It looks like that. Yeah.
The airflow could be pretty funky right here, though.
Yeah.
It seems pretty legit.
Yeah.
Yeah, it's pretty good. I bet you it's just, I mean, really, this causes a lot of airflow issues. Number one, it's coming off the roof, so it's curving. Number two, it wants to come in here and go up there.
Yeah.
This seems legit.
Yeah.